Have you ever pondered about the nature of motion and time? These two fundamental aspects of our existence are so deeply intertwined that we often take them for granted. Yet they shape every moment of our lives, every beat of our hearts, every thought that flutters across our minds. So, what exactly is motion? At its core, motion is simply change in position over time. It's the reason the sun rises and sets, the reason seasons change, and the reason we can travel from one place to another. Without motion, life as we know it would grind to a halt. And what about time? Time, just like motion, is ever-present, ever-flowing, and infinitely divisible. It's a non-stop journey from the past, through the present, and into the future. We measure it in seconds, minutes, hours, days, and years. We use it to schedule our lives, to celebrate milestones, and to remember our past. Time, in essence, is the canvas upon which the story of our lives unfolds. But what if someone told you that these fundamental concepts we take for granted are not as straightforward as they seem? Enter Zeno of Elea, a pre-Socratic philosopher who challenged our understanding of motion and time with his paradoxes. He proposed a series of paradoxes that seem to contradict the reality of motion and time as we perceive them. Zeno's paradoxes are a fascinating exploration of the concepts of infinity and divisibility, raising questions that have puzzled philosophers, mathematicians, and scientists for over 2,000 years. They invite us to rethink our understanding of the world, to question our assumptions, and to marvel at the mysteries of existence. So, buckle up as we dive into the mind-bending world of Zeno's paradoxes. Prepare to have your understanding of motion and time challenged, your thoughts provoked, and your sense of wonder ignited. As we delve into these paradoxes, remember, in the realm of philosophy and mathematics, things are not always as they seem. Imagine you wish to walk to the end of a path. Can you ever get there? A simple enough question, but one that leads us straight into the heart of Zeno's Dichotomy Paradox. In this paradox, Zeno proposes a thought experiment where you want to walk to the end of a path. But before you can get there, you must first reach the halfway point. Sounds reasonable, right? But here's where things get interesting. Once you reach this halfway point, you still have a distance left to cover. Now before you can cover this remaining distance, you must first get to its halfway point. And then the halfway point of the remaining distance after that, and so on, endlessly. This situation creates an infinite series of steps, or halvings, that you must achieve before you can ever reach the end of the path. Zeno argues that because there are infinitely many of these halfway points, you can never actually reach the end. This is the Dichotomy Paradox. It's a paradox because in our everyday experience we know that we can walk to the end of a path. We do it all the time. But Zeno's argument seems to show that this is impossible. One might be tempted to dismiss this paradox as mere philosophical speculation, devoid of any real-world significance. But it's not that simple. The Dichotomy Paradox raises profound questions about the nature of space, time, and motion. It forces us to grapple with the concept of infinity, not just as a mathematical abstraction, but as a physical reality. Moreover, this paradox has had a lasting impact on the development of mathematical and physical theories. It played a key role in the development of calculus, a branch of mathematics that is fundamental to modern physics and engineering. So, the next time you walk to the end of a path, take a moment to ponder the Dichotomy Paradox. It might just give you a new perspective on the world around you. In essence, Zeno argues that motion is an illusion, a fascinating perspective, isn't it? Picture the famous Greek hero Achilles racing a tortoise. Who do you think would win? In this absurd scenario, we might naturally assume that Achilles, the swift-footed hero, would easily outpace the slow-moving reptile. But what if we gave our tortoise friend a head start? This is precisely the scenario that Zeno of Elea presents to us in his Achilles and the Tortoise paradox. So, let's dive into it. The race begins with the tortoise 10 feet ahead of Achilles. The hero, confident in his speed, allows the tortoise this small advantage. Now Achilles is no slouch. He quickly covers the 10-foot gap. But while Achilles was catching up, the tortoise, slow as it may be, has moved a little further. Naturally, Achilles runs this new distance, but oh dear, the tortoise has again moved forward. No matter how small the distance, the tortoise always manages to move a bit while Achilles is catching up. This cycle continues on and on. Achilles always has some distance to cover to reach where the tortoise was. Though it seems ridiculous, according to the logic of the paradox, Achilles will never overtake the tortoise. This is despite the fact that in reality, of course, Achilles would easily surpass the tortoise after a few strides. This paradox is not about racing tactics or the relative speeds of Greek heroes and tortoises. Instead, it's a thought experiment designed to challenge our understanding of motion, space, and time. It questions whether an object can traverse an infinite number of distances in a finite amount of time. This paradox, like others proposed by Zeno, is a puzzle about the infinite. It forces us to grapple with the concept of infinity and how it interacts with our everyday experiences of space and time. It's not just a quirky story about a race, it's a philosophical and mathematical challenge. This paradox challenges our understanding of infinite series and the concept of motion. Is an arrow in flight at rest or in motion? This, my friends, is the crux of Zeno's arrow paradox. It's a mind-bending concept that strikes at the heart of how we perceive motion and time. Imagine an arrow zipping through the air. Now, freeze that scene. What do you see? The arrow, suspended in mid-flight, appears to be at a standstill. It's not moving to the left nor to the right, it's not moving up or down. In fact, it's not moving at all, it's just there. In this frozen moment, the arrow is at rest. But wait a second, how can that be? We know the arrow was in flight, we know it was moving, right? Well, this is where Zeno's paradox comes into play. He argues that if we could freeze time at any moment, any object in motion would appear to be at rest. This leads to the rather baffling conclusion that motion, as we understand it, might just be an illusion. Now, you might be thinking, that's ridiculous. I've seen arrows fly, I've thrown balls, I've watched cars speed by, I know motion is real. And you're not wrong. But Zeno isn't trying to deny the reality of motion. Instead, he's challenging our understanding of it. Zeno suggests that time isn't a smooth, continuous flow. Rather, it's made up of individual discrete moments, like frames in a film reel. And in each of these moments, objects are at rest. It's only when we stitch these moments together that we perceive motion. And this, in essence, is the arrow paradox. It's a philosophical puzzle meant to make us question our fundamental understanding of time and motion. It's not about proving that motion doesn't exist, but rather about suggesting that our perception of motion might not be as straightforward as we think. So, the next time you see an arrow in flight, take a moment to ponder this paradox. Is the arrow really moving, or is it simply at rest in each moment of its flight? Zeno uses this paradox to put forward the idea that time is made up of individual moments and motion is not continuous. What do these paradoxes tell us about our understanding of motion and time? Zeno's paradoxes, as intriguing as they are, don't just exist to boggle our minds. They serve as a profound and clever challenge to our everyday experiences and perceptions of motion and time. These paradoxes prompt us to question our assumptions about the world around us, and in doing so, they open up new avenues of thought and understanding. In our daily lives, we see objects moving, we feel the passage of time, and we do not think twice about it. Yet, Zeno's paradoxes throw a wrench into our intuitive understanding of these concepts. They suggest that motion, as we understand it, is an illusion, that time, as we perceive it, is not as straightforward as it seems. They question the very fabric of our reality, and force us to delve deeper into the mysteries of the universe. These paradoxes are not just philosophical curiosities, though. They have played a crucial role in the development of mathematical theory. They sparked debates about the nature of infinity, about the divisibility of time and space, debates that led to the inception of calculus, a cornerstone of modern mathematics. Zeno's paradoxes, therefore, are not just about motion or time, they are about the fundamental nature of the universe and our place in it. So, what do these paradoxes tell us? They tell us that our understanding of the world is not as complete as we might think. They remind us that there are still mysteries to be solved, questions to be answered. They urge us to keep exploring, to keep questioning, to keep pushing the boundaries of our knowledge. Zeno's paradoxes are a testament to the power of thought, the beauty of inquiry, and the infinite potential of the human mind. They remind us that even the simplest of concepts, like motion or time, can hold within them a universe of complexity and wonder. So, next time when you see an object moving or feel the passing of time, remember Zeno's paradoxes and marvel at the complexities of the universe.